My dear friends, as you know well, on the Do Roboty channel, we show a wide range of different jobs. Today we're going to deal with a rather unusual job. Something we haven't shown on this channel yet, the job of a metrologist. What does a metrologist do? With me is Tomasz. Welcome, Wojtek, a representative of Carl Zeiss Company. What are we doing here today?
We will show scanners, tomographs, coordinate measuring machines, contact systems, various systems that are very modern, which my team operates every day and helps our clients with, mainly in the industry, but not only there. Generally, in our daily work, we provide measurement services. A company has a problem with quality control. They don't know if something they've produced is good or bad. They have complaints. They want to make sure that everything they produce is of the highest quality. Then they can send us various parts. We can scan them, measure them with the appropriate technology, and then present it in the form of reports and results, right?
So do you just do measurements or also sell the machines?
We also sell these machines, and we implement them in Polish industry and at Polish universities. For example, today we have colleagues from another company who have already come for training. They purchased one of the expensive machines, and now they're with us for the whole week. We can show them what we do, how to use the machine they've already bought. We have something called a Scancobot, which scans the surface of a given part, in this case a casting. And it displays this in 3D, checks all the dimensions, checks the surface, and compares it with the ideal model. So Tomek is able, for example, to show our user or client where there are any discrepancies.
Aha, so the company sends you, for example, 100 pieces of one production batch to check each one?
Right? Yes, to check a batch, to see if, for example, after some technological changes, a given casting is okay or not okay. This is a big responsibility, yes, because, okay, we scan something and often issue something like a verdict, meaning we say whether the part is good or not good. There is really big money behind this and a lot of responsibility comes with it. What is very cool and interesting for our clients is that here in Tychy, in the center of such Polish industry, for example, automotive, but not only that, there are crowds of really well-educated people, engineers who can operate various programs and machines, choose the right measurement technology for the part being made, and interpret the results. And they simply have an external company to which they can outsource the part they don't like in their own companies, right? Quality control, checking something after someone else. We have a lot of people here who are simply passionate about these measurements. That's right.
I think now we'll talk about this passion. We'll switch over to one of the employees here who actually has this knowledge and knows how to measure it.
What you're seeing now is the scanning process itself, and what gets scanned is transferred to the software, where I already have a virtual copy of what's actually there. Then I compare it with the CAD model, which is something the designer made, something that's perfect. I have a color-coded display showing where I'm okay, where there's material missing, and where there's excess material.
If it's actually red, what does that mean?
That means I have a lot of excess material, too much material, exactly too much material. On the other hand, blue means there's too little material, and that's always the first analysis that the client, the technologist, or anyone in the company does. They can see what needs to be improved or changed.
What is the process for training a metrologist like?
At CC, we have something called the Metrologist path, which means we have every level for each machine clearly outlined, along with the specific training we need to complete in order to reach a certain level of metrological knowledge. It all starts with OCOM training, where we actually gain the basics of metrological knowledge, and then depending on each machine, we learn, for example, in my case, what the scanning process is, how these scans are performed, and how to process this data later. Here we have a different scanner. This one is a handheld scanner, where in fact with just 4 buttons, I am able to start the scanning process and quickly scan the entire geometry of this part. And you can come closer now to state this hole's diameter, right? Wow. So something that normally you would have to do here with a caliper running around, we are able to do with just 1 click. And in that time, you actually measured all the holes that are on this housing.
I'm curious about this machine. There's a chair here?
This is like the smaller one over there and works the same but has a larger working area. Here we have an area where we can insert an element up to 2 meters, but the largest one we have in Poland can fit an entire car body, and it's scanned by 2 robots, each with its own head.
Okay. And what are the weirdest things from your experience here at work that you've scanned or that a client brought in because something didn't match up?
The weirdest things were, for example, shoes, various types of imprints for things like seat production, couches, leaves. We've even had those for computer games. Oh.
So it's not just industry from what I'm hearing.
Not just industry, but also medicine, aviation, the military, all sectors where quality control is really needed. That's where we can help.
You have about 3 offices like that in Poland, right?
In Poland, we have 3 offices, the largest laboratory in the country, plus 1 in Poznan, and a training center in Warsaw. What's very interesting is that we also have a branch in Słupsk, which is our research and development branch, where the software we work with is actually developed right here in Poland.
Here we have more measurements. Welcome, Paweł, nice to see you. Hello, hi. On one hand, it's a similar system, so we're also scanning something, but it's not as mobile as the previous ones. And what kind of research is being done here? These are generally studies that show us what happens to the material during its operation. That means during bending, stretching, during various collisions, during impacts, or for example, during shootings. Thanks to a very high frequency, because here we can even record up to 2,000 images per second. And here we have an example of one of the frequent tests that we perform. Here we have a regular composite with carbon fiber. This type of profile can be used, for example, in the automotive industry for producing side pillars in a car. So side pillars, and now we're testing and checking whether they are, I don't know, flexible, durable, right? Yes, exactly. Here, for example, we can check how they behave during an impact, during an accident, which areas need to be reinforced and which areas we can skip, because, for example, they're not exposed in any way. And here, for example, by pressing gently, when it comes to the values, the plus indicates where stretching occurs. So this material is being stretched. Deformation on the minus side is where the material shortens, meaning the material is being compressed. Where we have compression, we can use less of the material to save, for example, on weight. Where there is stretching, we need more of the material, so we know that spot will need to be reinforced. What is it like to work in this plant anyway? Do you have your work schedule organized every day, or do materials come to you on an ongoing basis? The guys usually work here on site and have some kind of set schedule. On the other hand, my job is more mobile because the system itself is also mobile, so I do a lot of testing directly at the client's site. Every day, every test is always something different. It's rare for us to repeat the same tests unless we're visiting the same client again. However, there are so many clients that the variety of tests and the novelty of certain things I encounter is also very high. So I think that's what gives me the greatest satisfaction at work. And among the tests that are really the most fun, those are all the destructive ones and also the fast ones, meaning high dynamic tests, explosions and bullet impacts. So if a metrologist likes to destroy things, he'll find himself in this job too. All right, let's move on to the next machine. I was talking with Paweł about destroying components to test their durability. But if we already have a component, for example, damaged like this helmet after some kind of crash, we can check if it's still intact inside and do it without destroying it any further, right?
That's where a tomograph comes in, and thanks to our Metrotom system, we can scan the part, check all the components inside, see what they look like, and for example, decide whether a part is okay or not.
Well, yes, with helmets or child car seats, it's standard that even if there's a minor accident, the seat should be replaced in the car.
So then we put our part, let's say, into a big X-ray machine, but it could also be different parts, right? When it comes to mechanics, we check pumps to see if they're leaking, for example, right? We check medical devices to see if the right amount of fluid is in the right place, you know? Because we simply can't check it using other methods. And everything that's invisible, we can X-ray it inside here.
We turn on the X-ray. If we know the parameters and the material this helmet is made of, then we can more or less see inside it now.
It's already being scanned live, right?
Yes, this is a live preview now. The scan works in such a way that the object rotates 360 degrees. During this rotation, photos are taken, and then based on these photos, a reconstruction is made. So we have a scanned helmet. The whole thing has been captured, and now we can, so to speak, take a look inside. I've already found a crack in this helmet here earlier, as you can see.
And each of you here, as I see at these stations, is assigned to one machine, or do you move between whatever's on the shop floor?
It also depends on the person, but for example, I usually work on this one, and I also work on the scanners, so I actually mix it up.
And you're quite a young man, as I can see, so did your educational path start with studying in a technical field?
No, I actually ended up here by accident. I was working at my university's student science club, LEM, where we built electric motorcycles. And we just had this one situation where we needed to scan something, and at that time I was a bit responsible for marketing, looking for companies that could do it. And then when it came time for internships, I reached out to that company, so to speak, and I ended up staying there, which was really nice.
You see, my dear viewers, how you can turn your passion, hobby, or work in a student club into a job. So that was probably a few years ago when you were interested in or needed to do some measurements, right? Today, you do it every day, and you also enjoy it. So we know that we won't be riding in this helmet anymore, and we're moving on.
The technology is the same, also X-ray, ionizing radiation, but this is what's called an X-ray cabinet, so quick measurements, literally a few seconds, we take a few shots, check for defects, and see if the part can move on to the next stage of processing.
What's the difference between these two machines?
The technology is identical, but here it's 2D and there it's 3D.
Could a private individual use your knowledge, your technology, or is it all really only allowed and adapted for yes?
Mainly industry, we mainly work with companies, but sometimes there are interesting individual projects. For example, we once had a case where we scanned human skulls. The project was generally about scanning around 70 male and female skulls, and the skulls came from different time periods. So the goal was simply to check how these skulls change over the years. The operator has to be very familiar with the technology itself and know which defects are critical. A few pictures, as you saw, it took a few seconds, and now we have okay, not okay. Okay, we don't know, or repeat the measurement, and we click that it's okay, the part leaves, and we mount the next detail right away.
We moved from the tomograph to microscopes, which is something that I think is most associated with the company called Carl Zeiss. The same goes for lenses in mobile phones.
Lenses, binoculars.
Some telescopes.
Here we have a place where our colleagues work who operate the microscopes. These are industrial inspection microscopes. So for example, with this smart zoom microscope, you want to find out if something is damaged, scratched, or has some defect.
There are also microscopes we look into.
There are microscopes, let's say, like you might remember from school, or maybe our viewers remember too, but here, for example, we can examine cross-sections, metallography. Yes, we're getting into really detailed stuff here. And what we wanted to show is our Smart Zoom 100, just zoom in, check, done, what's it about? For example, on the production line, we have some parts we're manufacturing, and we can simply place a part here, in this case, a watch. So with really nice accuracy and resolution, we can take a closer look. Right, what's going on there? And for example, here we can see that there's some defect, which for instance tells us, okay, this batch, for example, some kind of plastic or something that's also visually very, very important in the automotive industry, like some knobs. Yes, it's not okay.
But as we just found out, you have very few private orders, like someone coming in with a watch like this. No. Is it that you just don't feel like it, or are the machines too expensive to be worth it for someone?
No, it always comes down to how you approach a given issue, right? If we're talking about money, what we see here, all these machines, that's a few million euros. I think this is the best equipped measurement laboratory in Poland. I'm 100% sure of it. And when it comes to the actual amounts, for example, a smart zoom like this, the price starts at around 13 or 14,000 euros. And you know, if you have to calculate that in your company, for example, if you get a complaint about a large batch, such a purchase will allow you to avoid that complaint and problems. In production, it pays off very quickly. No, nobody buys it just to have it, but to make a profit, right?
What are the operational costs of your work when someone brings something to you?
For example, a helmet, if someone came in and said, okay, I want to check it, see it, make a report, I think it would be around 800 zlotys, and we can check it and show them, okay.
Just this one, okay, throw it in the trash.
Throw it in the trash for 800.
That's how it was required, and that's why we left. Well,
but those are more or less the costs. No, because it's labor, machine time, depreciation. Also our knowledge, because very often it can happen that, okay, we do some research, but someone wants to know more, right? And we already have enough knowledge that we can suggest something to the client. I don't know, change the technology, the temperature, I don't know, the process. Yes, and this knowledge is also very important, right?
And it costs.
And by the way, just out of curiosity, when it comes to interesting facts about Carl Zeiss, I don't know if you know, but we were just witnesses to something. Artemis, yes, it orbited the moon in '69. Those photos you see on the internet taken from the moon were actually taken with lenses made by Carl Zeiss. Okay. We take pride in that because to deliver it there and to be sure that everything would work, well, just imagine there's no second chance to fly to the moon and do it again. So that's just one of many interesting facts in our company.
But there are definitely many more, because we also know that NASA uses your solutions, as well as brands like, I don't know, Tesla, Ferrari, and others for research and testing their components. Yes, so a global company for 170...
For over 5 years, yes, and a global company that not only deals with machines like the ones we see here, but we're also very deeply involved in medicine. We have a Vision Plus department. I don't know if you know, but all the phones in the world, really about 90 phones and the microchips inside them, are produced by a company that uses our light sources, our special spheres, and our parts. And it's precisely because we're able to manufacture these machine parts so precisely, the ones that actually print semiconductors, that we can communicate like this, yes, and these devices can keep getting smaller. Our company has many interesting facts.
Yes. I'm also glad we could bring the Do Roboty channel's camera here and show this to our viewers who know I sometimes feature manual work like laying paving stones, and other times visit companies like this, where few outsiders get to see the technology. That's why we're asking you now to leave us a lot of likes and enjoy this video all the way to the end, subscribing to the Do Roboty channel.
Here the job is to measure SMD components on a printed circuit board. These are small components, hard to access. This is where the O-Inspect machine comes in, which activates both contact sensors and optical sensors. We have two types of optical sensors, a white light sensor and high resolution cameras, and then using optics we measure our various components.
And here are the results we see on the screen. Well, what am I telling you as a metrologist?
Two things. The first and most basic, am I able to sell this component to the client, and is it compliant with what was specified in the drawing? The second thing, information for the operator working on the machine that he needs to make a correction, that the correction must be made on the machine tool, that the correction must be made on the robot that positions these components for me. At this point, the operator gets precise information on the amount and direction of the needed correction, so that this component lights up green for us, meaning it meets the drawing requirements.
It's super clean here, but does this kind of measurement really require a hyper clean environment where you can't even sneeze because the results might change?
It all depends on what we're measuring. It all depends on what we're measuring. Here in the laboratory, we maintain the environmental conditions at around 20 degrees Celsius, plus or minus half a degree. But there are class 0 laboratories, so-called clean rooms, where before I enter such a laboratory I have to put on a suit, step onto an anti-static mat and enter a vacuum chamber. Yes, there are such measurements, and that's where they look for tenths of a micron. Okay.
So with such wafers you can still cough or sneeze somewhere and it doesn't get too dusty?
But on the actual production line of such a component, I suspect there will be clean room conditions where any kind of contamination is unacceptable and the environmental conditions have to be maintained at a much higher level. And here we have our Ferrari. Its margin of error is below 1 micron, 0.9, but it's tuned by our service even better because in fact its margin of error is around 0.6 of a micron. So these are really extreme levels of precision. And where are the gears? Gears are elements where these accuracies are very, very high. We're looking for microns, tenths of a micron, so at this point the Prismo machine comes into play, where its range starts below 1 and ends around 0.3 microns.
And how does this machine work? Here we have these contact elements which we replace, right?
In the case of classic contact measurements, using various types of probes, usually ruby ones, we measure the geometry of our part. The tip comes into contact with the surface.
It touches it?
Right, it touches, there is a deflection, and the machine reads the information from the probe and the scales and calculates where it is located. But apart from this classic touch measurement, which was used decades ago, here scanning comes into play, which means I make contact with my surface and start moving along that surface. Okay. And these points are collected every millimeter, every half millimeter, every 100th of a millimeter. So at this point, I get a huge amount of points. So I actually get an image of what this surface looks like. During such a measurement with this solution, the machine also maintains a constant pressure force, so it's always in contact, constantly controlling how it tilts, how it operates. It constantly corrects everything to make the measurements as precise as possible and to get the most reliable results.
Here, I also noticed a certain calmness in all this work. People just walk around work, everything is being measured, but I don't see any pressure or anything like that.
You could get that impression. We often work under pressure though, mainly because of time. You know, if something is burning in a company, it's like, quick, measure it for us, check if we can keep producing. But generally, this job requires focus and calmness.
And also about matching the right method to the right object, because a client comes in with something and you have to know which machine is the right one.
Sometimes we can check it with one method, another method, compare them, or for example, if the results from the scanner don't give us satisfactory results, we move on to the tomograph, right? So I think that passion is also the foundation of this job. You really have to be passionate about it and have that curiosity, right? Why am I measuring something?
Satisfaction is great, passion too, working in a team, in a group, but let's move on to the savings for our client, to those machines that cost hundreds or tens of thousands of euros. So what kind of earnings can be expected in the future?
From what I see, and this is my knowledge, if we're talking about external manufacturing companies, whether it's in the automotive industry or in medicine, I think that we can earn between 8,000 and 12,000 gross. And if we want to keep developing here and show our passion, I think that's roughly how it's valued.
Well, it's a highly responsible job, really highly responsible. Look,
This is important.
what we do, because let's say if a company didn't manage, or let's say they produce something but they want to be sure it's made properly, then someone has to check it and be responsible for it. That's right.
And you know what? There's also something very important, the desire to grow. Because here, you know, today we're talking about these kinds of technologies. But for example, the company Zeiss is constantly working on new solutions. So new software comes in, a new machine comes in. No. Here, new standards are introduced, yes, which you have to learn. So for example, training, we also train a lot of people ourselves.
Exactly, that's what I wanted to highlight, the desire to grow. So if a viewer watching this almost to the end thought it would be nice to come visit you here. Earlier we said that this is a very inaccessible place when it comes to just walking in from the street. But what, can you make an appointment with you, test these machines, learn something?
Carl Zeiss Laboratory Taichi. You can call us, you can send us an email. If someone would like to, for example, take part in, I don't know, a training in technical drawing, the basics of metrology or position and shape tolerances, we invite you. We can, for example, add such a person to a company.
So you should mention you're from the Do Roboty channel and watch this material? Yes.
That it's from Do Roboty, we saw it here, I liked something. And then our colleagues who will be doing such training or arranging such training, we will suggest a big discount, for example, 50%. So for us, it will also be a cool thing to teach someone meteorology from the beginning, or to give them that first signal, okay, this is something interesting.
Well, all that's left is to take advantage of it, dear viewers. Thank you very much for watching this material all the way to the end. I'm very grateful that I could visit your company and show my viewers something else interesting that hasn't been on the channel before. Write in the comments which other companies or jobs I should check out, subscribe to the Do Roboty channel, and I'll see you in the next episode in a week.